Good afternoon, YouTube. Interesting document sharing this week. I was doing some testing based on talking to a couple of customers that were talking about this Kube-Vip. And I was quite intrigued by what the community is doing with Kube-Vip. And so what I wanted to do was test it, but test it with the big IP. Since the big IP is a full BGP environment, BGP router, I wanted to front end my Kubernetes cluster with my big IP environment, since it's there already. My big IP is an existing big IP, it's there already. And so I wanted to take advantage of the routing functionality that's available on that big IP. And so that's what interests me in creating this document and kind of sharing this information with you. There is a lot of examples with Kube-Vip, with Traffic, and with Metal OB, and with NGINX Metal, but there's not a lot of examples with big IP. And so I wanted to go ahead and test this out, maybe do some evangelization here, kind of talk about how cool this is. Maybe this is something that I want to share with my development team to see if potentially F5 can expand this. I'd be very interested to get some feedback from the community, from you guys. I ain't going to do anything without beachhead customers, without some examples of people wanting to use it. So what's really cool here is, in my traditional sense, I am front-ending my Kubernetes cluster with big IP, right? Big IP is existing, it's there today. I am doing all of my Kubernetes ingress administration with NGINX Ingress controller. So NGINX Ingress controller using NGINX Plus is running in the Kubernetes cluster today, and it's providing all of the ingress and load balancing services to all the pods, and the Kubernetes DevOps administrators or the DevOps administrators that are creating those pods are interacting with your NGINX cluster. Right? They don't necessarily need to know how the traffic gets to NGINX. That's the most important. The traffic's got to get into the cluster in this on-prem environment, right? If this was a cloud environment, I could use the cloud load balancer, right? But in this case, this is potentially on-prem, or if it doesn't have to be on-prem, it could be in the cloud, it could still use the same deployment, it really doesn't matter. And so what I really want to do is really configure or inject some type of public or virtual IP address into the network to generate traffic into the NGINX Ingress controller. Because once the traffic gets to the NGINX Ingress controller, it will then forward the right load balance traffic to the correct pod based on its host header, based on its path, etc. And that's what it will do. That's what it's configured to do for. That's exactly what it's going to do. And so Kube-Vip is kind of cool because in this case it demonstrates using BGP with NGINX and big IP. So in this case, the big IP is really just your BGP router. Now you might ask, do I have to use BGP? And the answer is no. You can use ARP. ARP's another option for Kube-Vip. But to be honest with you, boy, BGP, it's actually pretty simple, right? You do not have to do a lot with the BGP environment, at least in this case. But again, you kind of need to talk to your network administrators, maybe your big IP admin, to determine that. I'm going to show you how to enable BGP. So Kube-Vip doesn't only provide a public IP for load balancing. What Kube-Vip also does is provides the cluster with the virtual IP and load balances both, not only the control plane, but also Kubernetes services. That is really cool. My lab's pretty simple, to be honest with you. It's a 5-node cluster. I have one master and all worker nodes, and all I do is basically set up pods and mostly stuff around CIS and NGINX. I don't necessarily have a clustered high availability where I need lots of control planes. So in this case, I had to cheat a little bit, and I'll kind of show you that. But what you could easily build a rancher environment with a couple of nodes, and set up those nodes as potentially both workers or control plane nodes, or set up a bunch of control plane nodes and some worker nodes. And Kube-Vip will actually provide that virtual IP to load balance those control plane nodes. It's actually really cool across the cluster. So that's ultimately, I think, how this initially started. And then the whole purpose of this moving to do this right here, Kubernetes of type load balancer using, in my case, I'm using my external IP. So I'm going to show you there's no configuration I need to do here with regards to local traffic management. Traditionally, big IP comes with load balancing. There's nothing I'm going to do here. You can if you want. You can do many different things there if you want. But the primary focus of this document is really to expose Kubernetes services. And the Kubernetes service that I'm going to expose is the NGINX service with Kube-Vip. And as you can see, this project has evolved, and now we're talking about load balancing capabilities with Kube-Vip. We talked about that. So using this type load balancer, right, using type load balancer with NGINX is really to allow the virtual IP address to be associated or load balanced across the cluster. That's actually pretty cool. And then that address gets advertised by Kube-Vip to Big IP, and Big IP can advertise it out, right? You can redistribute into a different routing protocol, or what you can do is you can create some type of SNAT, which is a source address translation on the Big IP from Big IP to internal. So you can go external to internal, and you can inject that IP address into routing. There's many different things you can do here, but it's getting the address into the router's routing table so that the router can know how to route. And potentially, if this was on a private network, you could do that too, because it's going to expose it with Big IP. It's going to expose it to Kube-Vip through routing, and you could actually inject that into any routing network that you want, because you can choose the interface, which I thought is really wickedly cool. Any case, so continue. This is our architecture. So we have Kube-Vip running as a pod. You can run it as either a daemon set, or you can run it on a static pod. In my case, it's running in my master, so it's kind of like a static. However, I configured it using a daemon set. I have this Kube-Vip cloud provider, which is going to use something like a config map to actually configure it. But because I don't have any controller nodes necessarily, everything's running on master, I don't think that's working for me correctly. In fact, it's ignoring the config map, which is exactly what it would do. So I want to rebuild this with a bunch of controller nodes. But in any case, once you configure a service or expose a service of type load balancer, what Kube-Vip will do is it will take that address and propagate the external IP. Right. So let's go ahead and show you that, because we talked a lot about the configuration. So we want to show you how to enable BGP. So pretty simple. Go onto your Big IP and then go down to network routing domains. Go into your route domain 0 or whatever route domain you want to expose, and just add BGP right here. That's the one thing that you have to do. And then, of course, the second thing that you would have to do is to configure BGP on the Big IP. And to do that, you can go into the Big IP, you SSH in, you go into this terminal called iMesh. It's just a routing terminal, very similar now to like a Cisco router, enable config T, route BGP and your AS number. I use the default. My neighbor here, I'm using Kube-Vip as my peer group, so create the group. And then I'm using neighbor Kube-Vip, and there's my remote AS, which is what's going to advertise. And then here is my neighbor, and that's my master node. And so here you would provide all of your nodes, and in this case probably would be your controller nodes that you would then advertise back out to the Big IP, right? So if you look at the Big IP's routing table, once you've configured Kube-Vip and the pod is running, then what you'll see is the negotiation within BGP. And you can validate that on the Big IP by looking at the Big IP's routing table. So let's deploy Kube-Vip. So we deployed Kube-Vip. I deployed it as a daemon set, but it's actually running on the master. There's something there that points to the master. Here's my BGP peer. You can see it matches the same above. Here is my peer. This is the big IP itself. And I created this virtual address, which is, it creates for me, and this is what it would use to load balance the controller nodes, or the control plane nodes, if you had them. Simple deployment. You can kind of see it starting up here. You can see that it's starting right there. It's adding the peer configuration of the peer. It's beginning to watch for all of the load balance services. That is really cool. So once it finds a load balancing service, and you can see how it's communicating here, it says its peer is up and how it's communicating with the neighbor. I thought that's actually really cool. How the two big IP and Kube-Vip is actually communicating. And so very, very, very clean on the big IP side. And we'll talk a little bit about why to use big IP in a minute. So here I've created a controller. If you wanted to do a little bit more advanced, I can create a controller, but because I'm kind of using a static deployment, static node, it's ignored. It says that in the docs. So once Kube-Vip is running, what I'm going to do is I'm going to deploy my NGINX, so standard NGINX deployment. But the only thing that's kind of cool here with the NGINX deployment, other than being standard, is that it's of type load balancer. Now, you can specify an IP address. You can go and say type load balancer, specify an IP. But what I wanted to do is I wanted Kube-Vip to populate that IP. So because I'm using a static environment, which you can go and look here at the docs, Kube-Vip docs. This is the Kube-Vip docs. It tells you a little bit about static pod. I'm using a static pod that is running on my master node, and I'm exposing a service of type load balancer. It's basically just going to pick up an address. It's going to pick up an address from the specified interface, right? Which is what it's going to do. It's picked up the address from the specified interface. In my example, it picked up an address and configured that address. So it's actually kind of cool. But it would be nice if I could give that environment just to use the config map, because by using a config map, I have more control, and I'll talk a little about that in a minute. So this is kind of what I did in my environment. Daemon set would be the way to go if you were doing production, of course. So once I set it up of type load balancer, then I can kind of move forward. So I can deploy my cafe application. So this is the application that sits behind the NGINX, and you can kind of see here that I can see that my cloud controller is running, my daemon set or my static pod is running on master. You can see that's all running, and you can kind of see from the log here that this is kind of the same log as above. But what's really cool here is that once I configure that NGINX type of load balance, it gets the address associated for the external node, which I actually think is kind of nice. So let me open up another screen here and just show you kind of what I wanted to do, but I didn't want to rebuild my Kubernetes environment. So if I go to the daemon set, what would be really cool is for it to use this config map. And this would basically say that it's going to pull that IP address right there, or a range. You could use a range. But since I only really need one IP, what I wanted to do is say, hey, Kube-Vip, pull this IP. But because my environment is kind of just a lab, because I don't have active controller, because I don't have multiple controller pods, really just have one, it's just master, right? So in this case, it's ignoring this. But that would be cool to basically pull from a cluster node. There's lots of examples around this on the documentation. It actually talks about it right here. You can see how to deploy the Kube-Vip cloud provider, and then you create this config map. That's it right there. And that's basically a CIDR for global. Global means any namespace with that specific network. Or if you want to use a range, you can specify this specific range, or you can specify a specific IP. That's actually kind of cool. I actually kind of like that. Mine's way more simpler than that, but I didn't really care too much about what address was assigned. It's more about how the address gets assigned. You can kind of see that we start advertising this address with this address out to within BGP. You can see there's the service. Look how cool that is. The service gets populated. As soon as you create it, that's the magic right there. It's populating that IP address and advertising that address out across BGP to an external device, right? In my case, it's an F5 big IP. That's the magic. And think of that as almost like IPAM. In CIS, if it was CIS in this picture, instead of Kube-Vip, CIS would configure big IP with that 200.14, or it would pull it from IPAM and configure it. But because CIS is not in this picture, there's no automation of LTM, big IP LTM in this case. It's just really routing. And the purpose was to integrate Kube-Vip because customers are telling me, well, they don't have big IP LTM and they don't want to use big IP LTM. I'm like, okay, but big IP is still there. So what other options can we explore? And this is one of them here. This is the magic. This is the magic right here. This is the East data center, and you can see here that address is right there in BGP. That right there is, of course, the magic, and you can see where it's coming from. It's coming from that interface. So that means that this big IP, obviously the big IP can get access to that IP. Then what I can do on the big IP is many different things. I can take that IP, I can advertise it out of the public interface that points to the internet. I can redistribute that into some routing protocol. I could create a one-to-one mapping, external to internal mapping if I wanted to on the big IP using DNS. I mean, there's many different things that you can do with this. To scale this across potential two clusters, which would be kind of cool too, you could actually scale this, and you could do some type of BGP load balancing. If you had another cluster that was doing this, let's say you had a 14 and a 15, for example, then you could maybe push that out to a routing and specify a weight on that and do some type of routing load balancing between the two clusters, or potentially start to dabble with DNS. And that's where I want to take this. So you can kind of see I can easily connect to this virtual here. So let's give you a quick demo since I have this environment up. You can see here that if I go into the routing, so we go in enable here, and we do a show IP route. You can see there is my route right there. I took this one away because I didn't think I needed it. So there is my route right there, and I can ping that route. It's advertised right there. If I go to look at the interface, you can kind of see where it's getting it from. Like if I do an IP, you can kind of see it's pulling it from this address. It pulls it from the address because this is kind of how Kube-Vip works, because I expose this address, interface E192 in the configuration. If I go look up at my configuration here of my deployment, I expose that interface right there. So that's where it's going to pull that address from, and it just pulls an IP from that space. I don't quite know how it's picking .14. I think it's just picking it based on the CIDR, and it's just giving it .14. I noticed that there was no way for me to customize that. It would be great if I could go and customize it. Preferably what you would do is you would have multiple control plane nodes, and therefore you would then be able to move to the config map. That's kind of how I would want to do that. Just time. So if I look at if I go and try and want to expose the service, so kubectl get service NGINX service, you could actually see there is the address, and I could remove the service and or take down or remove Kube-Vip, turn Kube-Vip off Potentially it should release that. Should hopefully release that, but that's a different kind of testing outside of this. But yeah, that's pretty cool. And so that's exposing port 80 and port 443. And I can actually hit my application. You can actually see here. Now this resolves to cafe.example.com resolves to the virtual address. Let's bring in a DOS prompt. Here we go. And we can actually ping cafe.example.com. You can actually see right there. I have a local DNS that's just advertising that because NGINX likes the host header. If I don't specify the host header, it's going to complain. And you can see there, that's the coffee. So this is what's configured on the NGINX. You can do coffee. I also have a tea service, like in my example right there. And you can kind of see it just goes on. So there's the server address. This is the server address on the back end. This is the remote address. And I bet you that this is remote address. This is probably coming from Kube proxy. Yeah, this 3.198. I bet you this is Kube proxy. It's probably coming from the master node or one of the nodes. It probably come from the master node. It's one of the Kube proxy addresses. I could find out where that address is coming from. But that's kind of cool. So let's go back to the example here. So this is a document. This is a example of using Kube-Vip with F5 big IP. It was undocumented with F5 big IP. There was lots of examples with MetalOB and with Rancher and with NGINX, but I wanted to document something with big IP. So please let me know some feedback. I'd love to do I'd love to do some evangelizing here, potentially, do some development. But I really need some of you folks. I need some customers to want to test this or to think that this is a viable solution. This is just something that I've been testing on, reading about an open source community project. And so if there's actually interest here, then that's cool. What I would love to do is to see if big IP if CIS can use its IPAM as potentially a cloud provider. So if you actually look here, you can actually see that when you start looking at cloud providers, they actually decoupled the Kube piece from the cloud provider. So you could actually build your own cloud provider. You can see some of them here. There's the default one. There's NGINX Metal. There's K3S. They built their own cloud provider, for example, and a couple others. So this is actually really cool, this possibility of cloud providers. So, CIS today has IPAM, and what CIS can do very easily is update the type load balancer function, right, with the IP address from IPAM. So CIS would get IPAM and then potentially update the service type load balancer with IPAM. And then what F5 CIS potentially could do is, and this is not at all this is all hypotheticals, but potentially what happens then is maybe potentially work with Kube-Vip to do the ARP update or the BGP update, or maybe even DNS. In any case, it's different discussion here. I want to kind of show you what we have today. This is what we have today. What's cool about this, and I think this is what's really important, this is a open source project. It's quite there is development on it. You can kind of see there's people opening GitHub issues, and those GitHub issues are getting answered specifically on Kube-Vip. However, this right here with the router and the routing advertised is 100% supported. That means that you can actually open an SR. You can open an SR with whatever serviceability you purchase for your big IP. The NGINX Plus, if you buy NGINX Plus, this is supported. So this whole piece here is all supported, right? The only thing that's kind of community support in this case is Kube-Vip itself. I think that's really cool. So the solution that you actually look here is fully supported except for Kube-Vip, as long as you go and deploy NGINX Plus with big IP. So that's actually kind of cool. Futuristic stuff, anything can happen. give me some feedback. Let me know. Potentially, maybe do some investigation here. Potentially. But if you like this video, give it thumbs up. If you have any comments, please let me know. Subscribe to the channel. It's really important. I'm trying to grow this channel and therefore expose more of this content out to the Kubernetes community. And have a great weekend. Thank you.